Hey guys, thanks for watching this. This is our presentation for UConn Senior Design. We're part of the Computer Science and Engineering Department, and we did a project for ISO New England. It's a generator model verification result analysis system. Sounds like a lot, I know. It was, and it was a good time. So we're UConn Team 10. We're with the Computer Science and Engineering Department. We're under faculty advisor, Professor Wei Wei, great guy, Andrew Collins, Eric Flower, which is me, and Sam Marklin. We're all part of Team 10. This is a joint project between CSE and the Electrical Engineering Department, and we'll get into some of their contribution a little bit later. So our sponsor is ISO New England. Angela Gaspar is our project coordinator. We have Xiaoshuan Luo. I probably just murdered his name. I'm sorry, sir. He's our technical manager. And Guang Frankie Zhang, lead analyst. So background, ISO New England, as you know, is part of the organization that controls the grids in New England, and I think they keep the market regulated. But most importantly, they're concerned about grid disturbances. This happens in earthquakes, hurricanes, lightning storms. Something common up here in New England would be somebody drives into a telephone pole, it knocks over a tree. We have a grid disturbance and they need to rebalance. They want to verify these disturbances that they fit models that they have come up with, right? ISO wants to do this. They want to make more efficient so that they can attack these problems when they happen more quickly and get a better result for the public. So they simulate event models and they play back this simulation method. It uses real-time data. So in other words, when an event happens, you can see the result in a generator, and that's the reality of it. And they have some models that they figure on what's going to happen, and we want to compare those. So they asked for a generic event database that stores rich information about each event. They want application analysis platform and other data mining tools to be able to access this database. So it needs to be structured. They want a web-based GUI for managing and analyzing the results, and this is a sample of what they asked for right here in this picture. And then they also need to generate a formatted report. Now, this is because when the analysts take a look at these events, they want to see if they can extrapolate, interpolate any kind of data that would be helpful. So our answer, and this is our little version 0.1, first thing we did here, involves a technology stack including Postgres, Spring Boot, Apache Maven, Apache POI, JavaScript, and React. And that's our technology stack that we use. So the front end tech stack is basically composed of React and JavaScript. Very easy modular tools to use in creating little web GUIs.
Here's a prototype of our tool filled in with test data. The front end was built with JavaScript using React tools. As far as our layout goes, on the left side, you can see a list of all the events that occurred on the power grid. On the right side, you can see a list of all the generators in the power grid. In the middle, you have a bunch of options that allow you to filter the event data. In order to get some data to fill in on the right side over here, you must first select a generator and event pair. You could do this by selecting an event, populating the generator table with all generators that were involved in that event, then selecting a generator and loading the results. You can see on the right side here, there are a couple of graphs, a table. You can update a description for the event, as well as create a Microsoft Word formatted report for future reference.
After hearing from Andrew, here's our backend technology stack. So Spring Boot was the main web application development platform that we worked on. It's a Java-based application. And of course, we use the PostgreSQL, which is the preferred database at ISO New England. And then for the build system, to hook all this stuff together, the back end to the front end, the database, we used Apache Maven, which made everything nice and easy, especially when handling our dependencies. And then to generate the report, we used Apache POI, again, a standard at ISO New England, more on the report generator. So this is essentially the one web module they asked for besides just displaying and viewing the data. They selected generator events, so generators to events or events to generators. So you can compare one event across multiple generators or one generator across multiple events, how it's fitting to the model. Essentially, we had to take that data and fit it to this template form that they gave us. And for that, we used Apache POI, as mentioned before. There were a number of challenges when working with this project. For one, we had no access to any internal ISO environment due to security reasons. So we were not exactly sure what their data would look like, how it was being stored, how this data is getting into the system. So to get around that, we had to generate our own sample data in the end, our system was pretty agnostic to that fact. Just the fact that these were float values, or the value was of the same type, was essentially the most important part. And to get around not having access to a real deployment environment, we just tested on our local machines on the local Apache Tomcat server that was generated by the Spring Boot project. Due to these security concerns, we're actually not involved in the deployment integration, but we set up a document for ISO giving our recommendations about how to best deploy, how to best get this data in the system we set up, and a roadmap for whatever they might want to do next.
This was actually a fairly large project. It was across two different teams. Like I said, we had an electrical engineering team as well as our own team. We got advice and went through meetings with, of course, our faculty advisors, but also the people that were at ISO. There's so many names to mention here that I have to really say the biggest takeaway from this is just watching the machine. It's a very beautiful machine when all the participants of the team are working toward the same goal, and we can get it done. It's just it's the most amazing thing, and that's something I'll never forget.